All right, let's jump right into it. Welcome to this explainer. Today, we're unpacking the absolute bedrock of computing security. As a security analyst, you aren't just using computers, you are actively defending them on the front lines. And to do that, you have to speak their language natively. So, we're going to break down the two most critical environments you're going to use every single day, the Linux operating system and structured query language, or SQL. Here's how we're breaking it down today. First, the operating system conductor. Second, Linux and the command line. Third, managing files and access. After that, we'll dive into relational databases and SQL. And finally, we'll wrap things up with filtering and joining data. Let's get to it.
Section 1. The operating system conductor.
Think of the operating system as the master conductor of your hardware. As an analyst, you care deeply about the OS because it dictates exactly how memory and CPU are allocated, and that is precisely where malware loves to hide. Sure, it translates your keystrokes into binary, but it also translates malicious code into action. If you don't get how the OS manages these underlying resources, well, you simply can't defend them effectively.
Now this is a great comparison. Think of a GUI, a graphical user interface, like ordering from a rigid printed restaurant menu. You can only order exactly what's explicitly printed on the page, right? If a specific threat hunting tool doesn't have a pre-built button for what you need, you're totally out of luck. But a command line interface, or a CLI, that's literally like walking into a massive grocery store kitchen with an empty cart. You have raw access to absolutely every ingredient, allowing you to mix, match, and build the exact scripts you need to hunt down those really complex, sneaky threats.
Moving right along. Section 2, Linux and the command line.
Okay, so to actually use Linux effectively, you've got to understand this flow. It's basically how your text commands get translated into physical hardware actions. You, the user, type a command. The shell acts as your personal translator, interpreting that text. It hands the instructions over to the kernel, which is basically the main engine of Linux. The kernel then talks directly to the hardware to actually execute the task. And here's the real takeaway for us. As an analyst, your entire relationship with the computer happens right there in step 2, working directly within that shell. Because if you control the shell, you completely control the machine. Now, here's a wild concept. Literally everything you do in Linux is considered a file. And they're all organized systematically, like a massive upside-down tree. At the very top, you have the root directory, which is represented simply by a /. From that single root, all your subdirectories branch out endlessly to hold user files, system configs, apps, the whole shebang. So when you're tracking down a malicious file or analyzing an access log, you're really just climbing around the branches of this exact tree.
So instead of slowly clicking through folders manually, we use these core commands to just fly through the file tree directly. If you want to know exactly where you are, type pwd for print working directory. To look around, ls lists the contents. To climb to a new branch, cd changes your directory. And for modifying things, you've got mkd to make directories, touch to create new files, and rm, mv, and cp to remove, move, and copy data. But hey, a quick warning here, actually a huge warning. If you misuse that rm remove command at the root level, you will literally vaporize your entire system in milliseconds. So be careful, but once you master these, you'll be navigating at light speed.
All right, Section 3, Managing Files and Access.
I know, this 10-character string looks super intimidating at first glance, but is actually a brilliant 4-step code. It tells us the file type and the exact read, write, and execute permissions for every single person on the system. When you look at file details, the very first character tells you if it's a directory indicated by a D or just a regular file indicated by a hyphen. Then we just chop the remaining 9 characters into 3 chunks. Chunk 1 represents the user who owns it, Chunk 2 is the group assigned to it, and Chunk 3 is for other, which literally means absolutely everyone else. R is for read, W is for write, and X is for execute. Oh, and if a letter is missing and replaced by a hyphen, that specific permission is completely locked down.
Now, how do we actually change those permissions? We use chmod, which stands for change mode. Let's say you want to quickly secure a file. You type chmod, then G+W to add write permissions for the group, toss in a comma, and add O-R to subtract read permissions from others. Point that at your target file, hit enter, and boom, you've instantly stopped a potential data leak. It is absolute pinpoint access control right from the command line.
Let's talk about sudo. See, the root user in Linux is basically a God account. It bypasses absolutely all security checks. If malware hijacks your session while you're logged in as root, game over. It takes over everything. So instead, we use sudo before a command, which essentially translates to super user do this one specific thing. And here's a fun fact for you. If you fail a sudo password prompt, the system often generates a log warning saying, "This incident will be reported." Yeah, that is the absolute bane of junior analysts. But seriously, sudo is crucial. It requires your password, shields the rest of your session, and critically, leaves a solid audit trail proving exactly who ran that powerful command.
Okay, let's pivot. Section 4, Relational Databases and SQL.
So to successfully stitch massive mountains of data sets together into a relational database, you rely heavily on unique identifying keys. Imagine one table has all your employee data, and another table logs every single machine on your network. A primary key, like an employee ID, is a totally unique fingerprint for every row in that first table. No duplicates allowed, and it can never be blank. Now, a foreign key is simply taking that employee ID and dropping it over into the machines table. Suddenly, you've built a bridge. You can relate those two tables together to see exactly which employee is logged into which machine.
Now, to actually search these databases, we use SQL, Structured Query Language. And honestly, it's incredibly logical. The two foundational keywords are select and from. It seriously reads just like plain English. You're just telling the database, select these specific columns of information from this specific table. It's the equivalent of asking a friend to reach into a massive box of login logs and hand you only the failed passwords. In mere seconds, SQL lets you slice through millions of rows of absolute noise to find the exact needle in the haystack.
Which brings us to our final part, Section 5, Filtering and Joining Data.
If select and from give you the entire database, well, the where clause is your sniper rifle. Sure, the concept is a lot like filtering out bad fruit to find the fresh apples, but in a security context, we aren't picking fruit. You might tell the system to select all columns from the login attempts table where the country equals the USA. Just like that, a literal mountain of global noise vanishes, leaving only the specific logs you need for your active threat hunt. It's a real game changer.
And we can get wildly specific with these filters using operators. Let's say you don't know exactly how a country name was typed in. You just use the like operator with a percentage wildcard like US%. Bam, it finds the pattern. Need network patches applied in a specific month. Use between for the date range. You can use and when multiple conditions have to be met, like finding machines running a certain operating system and a specific email client, or broadens the search. And not is absolutely brilliant for excluding stuff, like returning all compromised machines that are not sitting safely in your test lab.
Now, what happens when your investigation needs evidence from two totally different tables? That's where SQL join commands come in, letting you merge them flawlessly. Using those primary and foreign keys we talked about earlier, an inner join is your go-to for strict matches. It only gives you rows that exist in both tables. But what if you want a list of every single employee in your company, regardless of whether they have a machine assigned to them yet? That's when you'd use a left join to keep all the data from your primary table while pulling in any matches from the second. Right join does the exact opposite. And a full outer join, that just throws the doors wide open, grabbing absolutely every piece of data from both tables into one massive, comprehensive view.
Okay, let's bring it all together. We've covered a massive amount of ground today in this explainer, from understanding how the Linux kernel drives hardware, to locking down permissions with Chmod, right down to slicing through millions of log entries using SQL queries and joins. Look, these are not just academic theories. These are the literal everyday tools analysts use to stop real-world cyber threats in their tracks. So as you look at your own networks today, I want to leave you with this thought. Now that you have the raw foundational power of Linux and the pinpoint investigative precision of SQL in your toolkit, what invisible vulnerabilities are you going to uncover, and how will you use these tools to defend your systems today? Thanks so much for joining me. Keep questioning and keep defending.